please draw it. Okay, and then from here you can find the limit. So the thing is, you have to know the limit of r and theta. Like this, your r should be start from the center to here. So your r should be not as usual like 1, 2, or 3, but they start from 0. 0 to 2 cos theta. How I got 2 cos theta? I have to solve this circle equation, and then I will get r equals to 2 cos theta. Okay? And then how about the angle? Your angle start from here to here. Another one here to here. I mean from the polar axis. So negative pi over 2 to pi over 2. Remember, you are focusing on the shaded region, the region that the question wants. Okay? I will give you this in the telegram. Okay, like this. Square root. If positive, negative means both. Okay, if positive, only just upward. So again, for this, the r is 2 cos theta, according to the question. And then your angle should be 0 to pi over 2. Okay, for negative part, sometimes if the question wants to trick you, they just use the negative section here. Okay, the question just restrict a boundary on the negative section. So, like this, you start from the axis here to here. Okay. Okay. So in this case, you can choose 0 to pi for the. Wait for a while. I don't know what is this. Okay. The radius is the same. I cannot write for a while. Okay. Let me check. I cannot write the. How to exit the annotate. Okay, it's okay. Okay. So here, from here to here, will be 2 cos theta. And the angle, you can start with 2 pi, 3 pi over 2 until 2 pi, or negative pi over 2 to 0. Okay? You can choose this, either this or this for this case. Okay? So just recall back, this is 0 to pi over 2, pi over 2 over pi, pi to 3 pi over 2, 3 pi over 2 to 2 pi, negative pi over 2 to pi over 2. This is pi over 2 to 3 pi over 2, pi to 2 pi, 0 to pi. Okay? Okay? So like this, you have two things. One is here, another one is here. So from here to here, y to x, which is pi over 4. From here to here is pi over 3. How I get? I just solve this. I just substitute y equals to r sin theta. X is r cos theta. I find the pi is pi over 3. We stop at here because this is the shaded region. Okay, this is the main thing. The others is your work from the engineering mathematics 1. Okay, so remember this. You can, if I ask you to do a poster, make sure you include all this. Okay. Okay. So we have done chapter 3 part 1. We move to chapter 3 part 2, a little bit harder than chapter 3 part 1. And so far, any question?
No, doctor.
Okay. So triple integral. So I think you can guess we have three. We have solid surface, and then we have triple integral for Cartesian, cylindrical, and spherical. Okay. Evaluate the application of volume, mass, center of mass. This is like chapter 3 part 1. Okay, but it is involving triple integral. Cartesian in, so we have integral in rectangular solid like before, integral in non-rectangular solid. We have 6 different ways, and then we have volume, which is triple integral 1 dv, and then we have cylindrical coordinate. This is nearly same as the polar, and this is spherical coordinate. It is for spherical coordinate, it is so much different. There is another one z-axis there. So as usual, this is the triple integral notation. We use solid G and dV. If this is 1, and this triple integral will be the volume. Okay. So if you find this word bounded below the, bounded below by, bounded above the, bounded above by, bounded below by means bounded above the, which means exactly above. Bounded above by, which means bounded below the. Below the means exactly below. Let's see, I have a cone. Say that I have a cone. Okay, inside the cone I have a cylinder. So I think this should be, okay. Okay. So let's say I said bounded below the cone. So the cone will be, yeah. You know why I cannot use highlight? Okay. Yeah. Bounded below the cone. If I said bounded above the cylinder, we don't have bounded above the cylinder. So bounded below the is clear. Okay, below the cone. We don't want the cone. Bounded above the cylinder, we don't have. So something about this, okay? But you have to know that above the means below by. Below the means above by. It's just the word. Okay. Rectangular solid. Okay, this is easy. This is same as the double integral. If the limit all are constant, you just put, and then you can switch this. If dy here, dx here will be CD and here will be AB. Okay, but it's actually we have 6 different adjustments. If I fix the inside one is dx, I can switch these two like this. Okay. If I want to fix the inside one, innermost integral is y, and this dx can be interchanged. Also, if I put dz is the inner integral, and this will be the outer integral. If I close this will be the double integral. Just the same. But now we have 6 different ways. Okay. Okay, evaluate this. I did this shit very easy. So triple integral dv. Let's say I want to choose dx, dy, dz. Okay, it's up to you because it is all are same. X0 to 1, and then I have y1 to 2, and z I have -1 to 1. Inside is z squared y dx. So first, if I differentiate respect to x, I will get dx from 0 to 1. So others is just copy. 1. So this is just z squared y e, right? E to the power 1, e minus e to the power 0 will be 1. I will integrate this with respect to y. I will get z squared over 2. Z squared over 2 e minus 1 y squared from 1 to 2. And then I left this dz, which is z squared over 2 e minus 1, and this is 2 squared 4, 4 minus 1 is 3. So I put 3 here. Okay. Now I integrate this respect to z will be z cubed over 3 from 1 to -1 to 1. So this 3 can be cancelled. We have z squared over 2 e minus 1. This is 1 minus 1 cube minus 1 is -1, which is 2. 2 can be cancelled. This 3, sorry, what is this? I don't have z here. When I already put z is here, so this is not z. So I left with e minus 1. E minus 1. Okay. Okay. Do inside one first. Do this first. After you have done that result, you have to integrate with y. And then z. So 2, 3, 1, 2. Okay, any question for this? I think this is easy. Okay. Is it okay? Okay. Okay, next is about the non-rectangular solid. This is a little bit harder than rectangular solid. Okay. Type 1, integrating over simple xy. Type 2, integrating over simple xz. Type 3, integrating over simple yz. So although we have type 1, type 2, type 3, but this can be dx dy or dy dx. There is another type 1, type 2 here. Dx dz, dz dx, dy dz, dz dy. So we have six different ways. Okay. Okay, another one is when you are integrating type 1, which means you are integrating with simple xy, the inside one should be dz. The outside should be dx dy or dy dx. So this z function of xy, and then they are reducing slower and slower. Say that I put dx dy. Okay. So the first must be function of xy or a constant or function of y only. Okay, or function of x only. But the second integral, okay, from the right, the x should be function of what? Function of yz. And this x should be function of yz. The innermost integral is function of xy. Second integral should be function of y, z. And the last integral should be constant. Let's say I put C1, C2. The outermost integral should be constant, cannot be a function. Okay, if I put dy dx, inside one should be a function of xy, but the second one should be a function of xz, or x, or only z, or constant. Outermost should be constant. Same for others. Okay, if you see here, if I put y here, y must be function of xz. Put x, x must be function of yz. Other than this letter, okay, other than this variable. Okay, okay. Let the G is a weight of the first octant cut from the cylindrical this by planes x and y0, x, y, x, x, x0. So first you have to sketch, because this is already solid. Wedge is like a cake. First octant. First octant means x more than 0, y more than 0, z more than 0. So it is in like a first quadrant if we sketching the 2D. So if I draw, okay, this is a cylinder project to x-axis. Somehow it is like this, okay? And then we have to cut at y equals to x, which means this is x, which is y. This cut here, cut, right? Cut. Okay. And then what I have here? What else you have? So let's see like this, okay? And then we have x equals to 0. Which one is x equals to 0? It is here, right? So it is involving here, here, and here. So when you cut this, you will have the shape. So this is y equals to x. This is a cylindrical surface which is parallel to x. Okay, it is moving here. And then you have x equals to 0 because you have to involve this. Because this here is everything in z, but your x is 0. This will show you the y equals to x. And this thing will be the cylindrical. We cut everything because we want only in positive x, positive y, and positive z. Okay. Okay, if you have to choose type 1, which is you are integrating over simple x, y plane, so that's why I have to shade this. I took this, I keep here. Why I do it this so? Because we can choose only one. If I use type 1, I have to sketch the bottom part. If type 2 means xz solid, which one is xz? Xz solid, which is here. I have to took this. Okay. If I want to took the back one, it is same as the xz. So this is xy. Same thing. Okay. Okay. So let's say I took this first. So and then I have to integrate three things, right? Dz, and then this dA I can choose dy dx or dx dy. So if dz, for dz first, they ask you to integrate z dv. So z we just copy, we just put here z. Okay, but I have to know the limit for z. Z limit, if I see here, Z limit, you have to see, you put your eye here, right? See here, Z is starting from here, which is Z0. And then the above one is here, if you can see. You can look from below also. This is your eyes. So if I see Z, Z is from here to here. So your Z is 1 minus y squared. Z is positive, negative, but this is first octet. I just choose 1 minus y squared. So that's why the limit of Z is 0 to 1 minus y squared square root. Okay, how about x and y? Let's say I want to choose dx dy. You have to choose either dx dy or dy dx. For dx dy, I have just choose this one. So from here, I can use type 1 as I learned from the chapter 3 part 1, which is double integral. I don't know, my pad is not so good as before, my writing pad. Okay, so type 1 means your x is from 0 to 1, because when y is 1, x is 1. And your y will be x to 1. Okay. So if I see here, type 1 cut at x. So this is y equals to x, and this is y equals to 1, right? So they cut the dx dy. Dx dy should be type 2, right? I think this is, oh yeah, they use type 2. Okay, they want to use type 2. Okay, type 2 in the double integral. So I have to cut like this. Type 1 for triple integral, type 2 for double integral. So if I cut like this, your y from 0 to x. Your x is 0 to 1. Yes. Okay. Your x, sorry. Again, your x from 0 to y. This is x0 and x equals to y. Okay. Dx dy. I have to write like this. Okay. So cut at y. Y is from 0 to 1. Your x is from 0 to y. So if I choose dy dx also can, no problem. If dy dx, I cut like this. So your x is same 0 to 1. Your y is from x to 1. So different, right? This is 0 to y. Okay. 0 to x. This is 0 to 1. Your x is, your y is x to 1. If I choose this. If I choose this, your x is 0 to y. So this might be confusing because we have type 1 and type 1 again in the double integral. So then you can get the answer. So remember, for triple integral, do inside first. Okay, if you integrate this, you get z squared over 2. And then you put this. And then you integrate with respect to x, this will be constant. So just put x from 0 to y. Don't confuse, don't put here to here. And then after that, you integrate this with respect to y. Okay, any question for this?
No.
Okay, next. Okay, you can use, as I said, type 3. Type 3 what? Type 3 is integrating over a simple. This is xy. This is xz. This is yz. So yz, which is one is yz? Yeah, yz. You choose this part at the behind. You cut them, give here. So the above part will be y squared plus z squared equals to 1. And here is 1. And for sure, for the what is this value? Do you know what is this value? Should be 1, right? See back? Yeah, 1. Okay, so as usual, your y, your z, your x, you should see the x first. So your x from 0 to y. Okay, see. Your dx 0 to y. You see here, if I erase this, okay. If I draw, you for the x, you have to put your eyes here. Okay, you see we have 1 and we have 2. So this part is y equals to x, and this part x is 0. So for sure, your x should start from 0 to y. That's why here 0 to y. And then the rest is easy. You can use type 1 or type 2. So let's say dy dz, which means I cut at z. So your z is 0 to 1, right? Your y should start from here, which is 0, until here. But this line is like this. So you have to modify your y equals to 1 minus z square root. That's why you have to put this. So remember, for this case, for non-iterated integral, if the limit is not given, you have to sketch, or the limit is in the region form, you have to see carefully. Okay. So after you know this, others is just a calculation. You will get the same answer, which is 1/8. Same also if I using the type 2, you are integrating respect to x. This is y, x, z. So when you're looking at y, you have to see the y part. Which one is y part? Here, right? The same thing. But your y should start from x. This one is y equals to x. This one is y equals to 1 minus x squared. So you have to fix which one you want to integrate. Okay. Simple xy, simple xz, or simple yz. Okay, this is easy. You can do directly. Okay. Okay, if I see I given the solution to you. Okay, like this. This question for here. Yeah, the first will be here. So do the inside one first. Integrate with respect to y, you get y from 0 to x. And then you get x cubed, you integrate respect to x. And then you respect to z. You get the same thing. So this is, I think, no problem. Okay, this is the challenging part. The second one, they ask you to sketch and then just write in 6 different ways. No need to integrate. So we have to see either the solution is wrong or right. Okay. Okay, first you draw. I think you can draw everything. This is very easy to draw. Just put 0, 0, you get 3. If I put for this exact plane, yes, I put y0. Okay, when y0, and then I put when y and z0, x is 6. And then when y z and x0, y is 3. So I just 2, 3, and 6. Okay, 2, and then we have 6, and also we have 3. So it is like this. And then you have to choose either which one you want to integrate over simple xy, xz, or yz. So for z0, For z0, you have x plus 2y equals to 6. Okay, so x plus 2y equals to 6. So from here, if x0, y equals to 3, and y0, x equals to 6. So the above part here is y equals to 6 minus x over 2. Okay, or you can write x equals to 6 minus 2y. Is either y equals 6 minus x over 2 or x equals to 6 minus 2y. This is just what we call just algebraic manipulation, because you can use type 1, type 2 here. It's already 2D. For this, y0, for y0, x plus 3z equals to 6, so z is 6 minus x over 3. So from here, when x equals 0, z is 2. When z equals 0, x equals to 6. So we have z 6 minus x or 6 minus 3z. Okay. For yz plane, x equals to 0. So you remember, for your test or final, please sketch this, although you already know. Okay? There's marks here. So z 6 minus 2y over 3, y0 z equals to 2, when z0 y equals to 3. Z equals to 6 minus 2y over 3, or your y should be equals to, this is not correct. So please amend on your notes. So this should be y equals to 6 minus 3 z over 3z, 6 minus 3z over 2. Okay. Not 6 minus 2z over 3. Okay. This is just manipulation. Okay. So you can plot 3D directly without the sketching traces. But to find the limit, please check the trace 2D from careless mistake to avoid careless mistake. So the DA now, you can choose. So let's say YZ plane first. I don't know. We start with XY first. Okay, we start with XY. So for XY, you have this function dz. Your z is what? From this equation, let's say I want to choose XY. I want to choose XY plane. So your z should be start from 0 until the above part. The above part is this. So your z should be 6 minus x minus 2y over 3. Z should be start from 0. So 0 to 6 minus 2y, 6 minus x minus 2y over 3. Okay, done. Your y, so they choose dy dx first. So if I cut this, say I want to cut here, or cut this same thing. Say I choose this first. So this is cut at y, dx dy. So dx dy, your y start from 0 to 6x minus x over 2. Okay? dx dy. Your x should be 0 to 6. Check. 0 to 6. Correct. 0 to 6. 6 minus x over 2. Is it correct? Your y is 6 minus x over 2. Yes, this. Okay, we check for YZ plane. YZ plane, Z is the same, and let's say dy dz. Dy dz, which one? Here, okay. So dy dz, type 1, say that I cut here, which is dy dz. So dz is 0 to 2. Dy dz. Y will be from 0 to 6 minus 3z over 2. Okay, this is wrong, right? 6 minus 3z over 2. Okay, this is for dy dz. Yes, if I cut like this is dz dy. So dz dy. So y0 to 3, dz dy. dz will be 0 to 6 minus 2y over 3. 0 to 3, 6 minus 2y over 3. Yes. Okay. Okay, Ken, any question for this? So I can produce this in 6 different ways. Ken.
Can, bro.
So done. Okay, application. So it's just a continuation from the above part. If the fxy equals to 1, the volume will be 3 integral 1 dv. Okay. If the limit is not given here like this, you have to sketch, but this is just the same thing. And this will be difficult part. So I have to see the answer. Z equals to y squared, z0, x0, x1, x1. So this is what? This is parabola. So what you have, but all are positive one, except for this. Okay. Yes, yes. The first one should be easy. Okay, the first one should be easy. Second one, you have to sketch. Y equals to z squared. Z equals to y squared. Z equals to y squared, which maybe you have to write like this. And then you just move like this, and then y is negative 1 to 1. So you have to consider y negative 1 to 1. X equals to 1, which is this, the width. This will be the x. Your y will be from left to right, and then your z from 0 to, this is 0, and this one is y squared. Actually, it is not ending, but we cannot draw very big, right? So from here, if I want to use dz dx dy, like this, I like type 1, okay, which is more easier to see. If you put your eyes here, okay, you say that I put my eyes here, okay, I just can see an rectangle, which is this. If I put my eyes here, I just can see the parabola. If I put your eyes here, again I see the rectangle. It is like if you compress everything until the bottom part. If you compress here, what do you get? Like this. Okay, so that's why this is the region. It is more easier. How about your z? Your z is from 0 here and until y squared, because z is y squared. Z must be function of x or y, or both. Your x must be function of y, or a constant. Actually, if you not sketch it, also you can do directly, but it's better to have a good explanation, geometrical explanation. But in your exam, if you don't provide this, you will have and you will lose some marks. Okay. Okay. So after you know this limit, the other thing should be easy. Nothing much. Okay. Your z is 0 to y squared. How about dx dy? You can choose for dx dy or dy dx. If I choose dx dy, means this is type 2. I cut at the here. Your y is from negative 1 to 1. Your x is from 0 to x is 1. So you have to able to see, to extract them and put the 3D back and extract to 2D. So something like this. You are extracting this bottom part to here. Can you see example question 4? Okay, sketch the solid. And okay, for A, we have this. Same thing. We have negative. This is just a circle only. 0 to y over 6, which means you have cut plane. The plane is cut with this. They cut. Okay, so that's why they look like that. It's like we cut the Pepsi can or Coca-Cola can to like slant, a bit slant. Okay, and then I have y negative 3 to 3, and then this is for circle actually. This is a cylinder, positive and negative circle. Okay, I cut at here because it is y plus 6, and I left like this. And then you have to choose whether you want to use type 1 or type 2. If I use this is, for most probably I'm using type 1. So if I use type 1, sorry, this is different, sorry. So this is thing. Okay, for B, like this. 1 minus y, it's again, it's cut at y equals x squared. It's a parabola, like this. And then negative 1 to 1 will be the x. Because this is the question, right? You follow the last one first, negative 1 to 1, and then your y is y squared, like this. Okay, if you can see, this is x and y, and then your z is from 0 to 1 minus y. Okay, so others you can solve by yourself, and then you have to see which one you to choose. Okay, Ken, any question for this? You can study the solutions well, actually, so everything is here. Are you okay? Okay, we rest for a while and then we move to cylindrical. Okay, so cylindrical will be the last subsection for today. We have another 1 hour, so try to study first. If any question, you can ask. Okay, now we will continue the cylindrical coordinate. So for cylindrical coordinate, the x is r cos theta, r equals to r sin theta, z equals to z, and your dv will be r dz dr d theta. Fixed. Okay, no change. So your z is function of r theta, your r is function of theta, your theta is the constant. There's extras that are there. Okay. Like before this, for polar coordinate, your dA will be r dr d theta. So you just add. So you can put this as your way to remember in the poster later. Maybe I will ask you to do poster again. Okay. Okay. Next will be for sphere. You can also use the spherical coordinate for coordinate. Yeah, sphere is the next subsection. So we use cylindrical coordinate because we have a cylinder problem. We have cylinder with the plane or cylinder with the cone, and this is parabola. Okay, parabola, and then we have circle inside, and this is sphere. For spherical coordinate, better use the, for sphere we use spherical coordinate. Okay. So okay, this is different. So remember your theta move from positive x. For 3D, here is positive and here is negative. This is your theta. Your r should start from origin to here. Origin to here. Okay, here is no z because in this plane, this is r theta. no Z. No Z here. So here we have R, theta, and Z. Okay. Okay. And Z is just increment here. Okay. Okay. So if you see here, okay, you don't need to know this. So R theta Z. Okay. So Z is function of R theta. Your R is function of theta. Theta is a constant. And fix this. Okay. Okay. So remember, your DRT data is actually a projection from XY plane. So if R at theta, you just see the XY plane. Is that the increment or decrement? This is so easy. For cylindrical, it's easy than the spherical. Okay, use the cylindrical coordinate to evaluate this. Okay, first you have to sketch. Z equals to 0, Z equals to this, Y equals to this, Y equals to this. So this is just a cylinder, right? And then this is the X. Okay, they give the limits, you have to sketch. Okay. For this question, I think see the answer, right? Example 1. We don't have here. Yeah, this right. Okay. You see Z equals to 9 minus. We have Z equals to 9 minus x squared minus y squared. And we have y equals to square root 9 minus x squared plus minus. If you square both sides, you have x squared plus y squared equals to 9. And then x equals to plus minus 3. Okay, is it same? At xy plane, z equals to 9. Yes. At xy plane, z0, you have x squared plus y squared equals to 9. Okay. And then what have? What we have? X squared, y squared equals to 9. When y is 0, z equals to y squared. When y is 0, okay, they use the traces. Y 0, z equals to 9 minus x squared. Okay. Can you see it? Let's say I want to choose xy plane. XY plane. So z is 0, we'll get a circle. If y is 0, you have z equals to 9 minus x squared. Okay. Okay. Okay, let me see. So z equals to 9 minus x squared minus y squared. So let's say I choose z0, which is xy plane. You have a circle with radius 3. Okay. And you when x is 0, which is yz plane, you have z equals to 9 minus y squared. Okay. And then when your y is 0, you have z minus squared. Okay, what is this actually? How to sketch this? This is just a circle. 3, 3. Okay. And then this is y, xy. So for this, z, y. So when y is 0, that is 9. And then when z 0, y is negative 3, right? So it is. Okay. I think this is the same. Z, x. So you have the same thing. Okay. So what else you have? You have x equals to 3. You have x equals to 3, y equals to x equals to negative 3 to 3. Have x negative 3 to 3. That is here. Y is a circle. So you have parabola, not like this. I think the terbalik, it is reverse. Yeah, here, yes, this is the example. I cannot find just now. Yeah, this is the example. So you get, if I merge all this, I will get this. Yes, this. And negative 3 to 3. Your x also negative 3 to 3. So from here, your r theta should come from this area. So your r is 0 to 3, and then your angle 0 to 2 pi. Easy. And your z, yes, your z is from here, z0 and z here, which is 9 minus, your z is 9 minus x squared minus y squared, which is 9 minus x squared plus y squared, which is r squared. Remember, for cylindrical, everything should change into r and theta. Okay, the solution is here. You can study, and then you can just put, and then the order should be r dz dr. Your z is from 0 to 9, or 9 minus r squared. Your r is 0 to 3, your theta is 0 to 2 pi. Sometimes you have to split this plus plus plus. So that is a difficult thing, difficult part. Okay. And others is just a manipulation. Okay, understand for this case. Understand?
Okay, Doctor.
Okay. Okay, question 2. Okay, see. What do we have here? Okay, limits is given. Okay, actually you can directly do using without the cylindrical, but it is hard because the region is like circle or elliptic or parabola, so you can use the cylindrical for easy purpose. Okay, for convenient purpose. So for question 2A, you have like this. Okay, same one question. But this is what? Some sort like hemisphere with radius 2. This is circle, right? Circle relates to cylinder. So you have sphere and cylinder. Okay. So to see this, if you can see this, we will need the integral 0 to 1, 0 to something, 0 to something. So 0 to something means everything in first quadrant. That is the key, right? Everything in the first quadrant. That's why the intersection between the sphere and here, we just take the inside one. So the angle will be 0 to pi over 2, which is first octant. Your radius should be 0 to 1 because the cylinder is inside. The cylinder is smaller than the sphere, hemisphere. So that's why you take 0 to 1, not 0 to 2. Angle 0 to pi over 2 because of the first octant. Everything starts from 0. 0 here, 0 here, 0 here. We don't consider the negative y, negative z, negative x. Okay, how about the z? Because we will change the dv to r dz, dr d theta. The dz will become from here. Actually, without drawing also you can do, right, directly. Okay, but you have to show. So this is square root 4 minus x squared plus y squared in the bracket. So this is eventually is a r squared. Remember, you have to follow whatever you have learned in the polar coordinate. X squared plus y squared equals to r squared. And then the rest is the equations. For 2b, okay, we have to sketch this. Z equals to x, z equals 0, x equals to this, x equals 0, y equals to -1 to 1. So if I draw this, this is just a line. Okay, it's a line, y equals to x. And then what else I have? This is a circle, right? Circle, but your y should be -1 to 1. So this is your y, -1 to 1. Okay. So see, if I draw for 3D, it will be like this. It will be a little bit not so nice because z equals to 0 to y, which is a plane. And then if I draw this, it is a circle, right? Circle, which is this. And I want the y is -1 to 1 because they already fixed the y is from -1 to 1. So I have to draw in -1 to 1. Yeah, like this. Okay. So if I change the position here, the x and y, maybe you can see more clearer. You can change, okay? It's not easy to draw 3D for x, y, z like this. If I choose the y is here, z is the y is and x is here, and I move the x into the right part, the behind part, x positive here, so I can see the easier sketch. Okay? So from here, so if we project to x-axis, we will get a cylinder. So that's why we use cylindrical coordinate. It's easier to use. Okay? So your z is 0 to r cos theta. How? It is from here. Because this line is square root 1 minus y squared. If I do some calculations, r sine theta, I think squared. Then I will square both sides, I get r squared. Or square theta plus r sine r squared, sine squared theta, get 1. Okay. Oh, sorry, this is 1, right? So to see how she get the r cos theta for z. Okay, for Z. Okay, because the R, okay, if this is negative pi to pi, because one is here, the angle, the R is here. So we have to find R cos theta, how he get how R cos theta. Oh yeah, we have Z equals to X, right? From here, okay, the easy way to see is Z is 0. So Z is 0, R will be 0. Z equals to X. So which means this is R cos theta. So you can directly say that Z from 0 to R cos theta. So that's why they put here R cos theta. So this is the easy way. So sometimes we can see without sketching, but we have to sketch to get a mark. Okay, can. Then others is just calculations. Maybe some of you can use the identities. Okay. Okay, application. Volume will be triple integral 1 dV. The dV is R dz dr data fixed and fixed. Okay. And you can see some example here. Okay, we can see some example here. This is it's not a circle. Is it circle? What is it? Circle, right? Or parabola? It is a parabola, right? Okay, it is a parabola. And then you have Z equals to 9. Easy. Okay, so the projection here is a circle, which is you have to use the cylindrical. So your Z is eventually 0 to 9. Okay, your R is 3, 0 to 3. Okay, your angle is 0 to 2 pi. You have to take this projection because I know this part is dx dy actually. The projection of this cylinder is the circle. So that's why I will choose circle cylindrical coordinate. So make sure when you see this equation, you already know, oh, this is the parabola. It is upward, not downward, okay, because it is positive. And then it's easy you to do other things. Okay. Second one, we have a circle. Okay, this is a circle, and this is again a parabola, and we have Z0. Okay, okay, okay. It is shift a little bit right to the right. So we just take this part only. We don't want to consider this. We see which one is bounded or intersect. Okay. So your Z will be from 0 x squared plus y squared, which is r squared. Your R, you see your R will start from here to here, here to here. So that is why you have to solve this. You can get the R, which is 2R, which is 2 sin theta. So that's why your R is 2 sin theta. And then your angle, if I took this, the round shape here, from here to here, which is 0 to pi. So this is a challenging part to get. And others is just formula. Remember your dV is R dz dr d theta. Okay. So the third one. This is again a parabola, a circle. It is just the same thing. Okay, is this a bounded below, bounded above? You just say bounded. Okay. So you will end up with a circle, right? If I press this, it will become a circle. So the Z is equals to R squared. Okay, and then your radius will be 0 to 2, and your angle should be 0 to 2 pi. You see back this, okay? Okay, spherical will go next class. But for this case, okay, what is the surface? I identify the surface from this picture. What is this actually? What is the shape? Ice cream. Can you guess?
Parabola.
Is
Parabola.
um, parabola. Not exactly. Try to guess again.
Hemisphere.
Yes, it is a hemisphere. Okay, it is a hemisphere. Yeah, parabola means maybe the thing is not the same, but it is hemisphere. And this is the actually is the cone. Okay, so maybe we use ice cream cone here for spherical. Okay. Okay, any question for this? Any doubt? I think this is a little bit hard to you to digest because we try to see some YouTubers, okay, about type 1, type 2, type 3 for triple integral, that because there's a 6 different ways. So master that first for iterated integral or non-iterated integral. And then study for the cylindrical also. Okay. Is it okay? 10.
Yeah.
Can Doctor.
Let's stop first. So take rest and then study back. Whatever you have learned. Okay. Assalamualaikum and good evening.